Hello guys, in this video I want to go over imaginary numbers, or complex numbers rather. So basically, um, this is like the next part of college algebra, um, and so I want to go over just, some definitions as well as maybe some examples. So a complex number is a number that is of the form a plus bi, where a is the real number and b is the imaginary number. So, some examples of that. So basically, it's like if we have two, let's say, let's do 2, and then plus, kind of zoom in a little bit, 2 plus 3i. So 2 is my real number, and 3i is my imaginary, because it has an I next to it. And then, like I said, an imaginary number, so right here, an imaginary number is basically I. So, and then there are two important rules to remember for imaginary, for the, for I, and that's that the square root of -1 is plus or minus I, because if you take, so I squared is -1, and let's see, hold on, and then negative I squared, let's see if this is true. Hold on one second. Actually, I'm changing that to I. I don't think it's plus or minus. I don't think so. I know for that part it's just it's just I, but when they talk about other square roots, like the square root of 9, that can be plus or minus 3. I think that's where that comes from. So if I say the square root of 9i, or I'm sorry, the square root of -I, or -9, excuse me, this is equal to the square root of -1 times the square root of 9, which is I times plus or minus 3, right? Which is plus or minus 3i. That only goes if they're asking for the positive and negative ones. I don't know exactly how they did it in college algebra. If they do just ask for the positive answer, then it would just be the positive 3i. I was taught in algebra 2 in high school that it was always both plus or minus 3i. And then another thing here is that I squared is -1, right? So I squared is always -1. Now, another thing that I wanted to go over is how to graph a complex number. So a complex number, yeah, like I said, it's of this form, right? So a complex number is like 2 plus 3i, etc., right? So then over here, the way that you graph a complex number is here's 1, and then over here is -3i, right? So this point is actually 1 minus 3i. It's kind of like the x and y axis, but it's real and imaginary, right? So the real number is kind of like your x axis, and the imaginary is kind of like your y axis. So it's kind of like plotting points, but not exactly. I mean, it is, but it's not in terms of x and y, that's for sure. And then over here, I kind of went over the way that multiplying complex numbers goes. So it kind of makes more sense if you do an example. So like 2 plus 3i times 3 minus 4i. Let's do 2 times 3, and then plus 2 times negative 4i, and then plus 3i times 3, and then plus 3i times negative 4i, right? This is 6 minus 8i plus 9i, and then it's going to be minus 12i squared. Now remember, I said that I squared is -1, so I squared is -1. That's because if you have the I is equal to the square root of -1, if you square both sides, you get that I squared is -1. That's how you get it, right? So here you would have 6 plus I, 9 minus 8 is I, and then minus 12, and again times -1 because I squared is -1. So then this becomes 6 plus I plus 12. So then combining like terms, we have 18 plus I, right? So then we go on to this idea, and this is basically like the sum and difference pattern of like when you multiply a plus bi by its conjugate. And the conjugate over here, like I said, it just means if you have a plus bi, the conjugate is going to be a minus bi. It's kind of like when we did square roots, right? So you know, the conjugate of a plus bi is just a minus bi. So that doing that, you actually get a squared plus b squared. So if I do an example, so if we look at this example, all we really have to know is, so if you guys remember the sum and difference pattern, let's say that this is u, and let's say that this is v, right? So this goes as the following: u plus v times u minus v equals u squared minus v squared, right? So it goes something like this. However, when you're doing complex conjugates, or when you're multiplying it like this, really what this means is that you're gonna have, so let u equal 3 and let v be 2i, right? If you do this, you're gonna get that, let's say 3 plus 2i times 3 minus 2i is equal to, and it's going to be the quantity 3 squared minus the quantity 2i squared. Okay, so this is 9, and then we have minus, it's going to be 4i squared. Now this actually becomes 9 minus 4 times -1, which becomes 9 plus 4, which is 13. If we do this as the quantity 3 squared plus 2 squared, we get 9 plus 4. So what does this tell you? Which is 13. So what does this tell you? when you're multiplying it by the conjugate, all you really have to do is square the 3 and square the 2, okay? Now, if you don't like doing that and if you want to work it out, that's completely fine. I actually work it out. I don't usually use that rule, but if that rule makes it easier, then yes, use it to your advantage. And then another thing, and I think this is the last thing that I wanted to go over. Actually, there was one more thing. Dividing complex numbers. So, for example, 3, let's say we have, 1 second, so, 1 second, guys. So if we have something like this, right, we need to multiply the denominator by the conjugate, okay? So multiply denominator by its conjugate. And like I said, if we have something like this, so we have 2 plus 3i, the conjugate is 2 minus 3i, so we're gonna go ahead and, if we rewrite it, we're gonna go ahead and multiply by the conjugate, 2 minus 3i on top and bottom. So then this becomes 3 minus I times 2 minus 3i over, and like I said, it's going to be, this is 2 squared minus, and then it's going to be 3i squared, right? So it'll be, so then this is going to be 6 minus 9i minus 2i, like this, and then plus 3i squared, right? Now, you're going to put it over, and then it's going to be 2 squared is 4, and then 3i quantity squared is 9i squared. So then this becomes 6 minus 11i plus 3 times negative 1 over 4 minus 9 times negative 1, right? Which is equal to 6 minus 11i minus 3 over 4 plus 9, which is equal to, so we have a 6, a negative 3, so it's 3 minus 11i over 13, and we can write that as 3 over 13 minus 11i over 13. Okay, you always write, when you write it in standard form, I think I went over that, but when you write it in standard form, I don't know if I went over that. You always write the real number first and then the imaginary number. So that's standard form, right? And yeah, so I believe, and then one more thing, when you're doing powers of I, so for example, we have I to the 21st power, we can rewrite that as I to the 7th power to the 3rd power. And then we can say that I to the 7th power is I times I times I times I times I times I times I. Yeah, so this is negative 1, this is negative 1, this is negative 1, and this is I. Remember, I'm getting negative 1 because the square root of I, or I'm sorry, the square root of negative 1 is I, so I squared is negative 1, okay? So then this becomes 1, this becomes 1, and then times I. So really this is 1 times 1 is 1, times I is I. So I get So this part here becomes 1, or wait, no, I'm sorry, I cubed. And then we have I times I times I, so it's going to be I squared, which is -1, times I, which is -I. So really, this whole thing becomes -I, right? So that was just a very quick, like, how do you say, a very quick, review, or not review, but like, a very quick overview of, like, the complex numbers. I believe I went over everything. One second. The last thing that I want to go over is the fact that the absolute value, I don't know if it's the absolute value or the magnitude, I can't remember. One second. Okay, well, absolute value you don't actually go over until pre-calculus, at least I think. So I'm not really going to go over that in this video. But yeah, so that is what imaginary and complex numbers are, guys. That was what the whole, I guess the entire section was about. And yeah, if you guys have any questions whatsoever, please let me know. And with that being said, guys, thank you so much for watching. And please like, comment, and or subscribe. And I will see you guys in the next video. Bye, guys.